the software equation. Now this software equation, if you see here, there are various variables. So this is a multivariable, a dynamic model. And what it is assuming? It is assuming a specific distribution of effort over the life of the software development project. And from where it has come? The software equation. This has been derived from productivity data collected for over 4,000 contemporary projects. Okay, from there it is derived. The equation is like this. E is effort. It will be in person month and person years. LOC is line of code. Please understand, it is not KLOC. Most of the expressions we have seen earlier are in KLOC. B is the special skills factor. And then we have the P here. P stands for the productivity factor. We'll take the example. And this T is the project duration. This can be in months or years. Okay. Normally we take it in years. So let me tell you again, in this software equation, effort will be in person month, person years. The time, which is project duration, in months or years. And this B is the special skills factor. This P is the productivity parameter. Now what this productivity parameter says, this says about what is the overall process maturity, say CMMI, which level you are, and the management practices in your organization, the extent to which good software engineering practices are employed, are used, what is the level of programming languages you are employing, and the state of the software environment, the skills and the experience of the software team, and finally the complexity of the application or the system or the software you are working upon. So this comes under P. So let us say we have already known E, B, P, T now. So this is the productivity factor, P. This, if you have a real-time embedded software, so P value for this will be 2000. Real time, that means you want response with bounded time, and the embedded software like your micro oven or your washing machine, you have embedded software. You will take P as 2000. P is 10,000 for any telecommunication, data communication, this software and this system software like drivers. P will be 28,000 for, say, business system application. That is, a lot of things are involved here. The productivity parameter P, this is derived not only from the past experience, that is the historical data, but also the local conditions for the past development. So we'll take an example where P will be different, and this is how this P will be given. The software equation has two independent parameters. What are these? See, B and P are prescribed value. We know it. So the line of code will change for a product and the project duration. So line of code and project duration, that is the time, that is going to be your independent parameters. So let us say we have a function y equals fx. Now this x is the independent value, independent variable, and y is the dependent variable. So E is the dependent variable on the LOC and the time. So Putnam and Myers, they simplified this estimation process and with certain restriction, and they suggested equation derived from the software equation, which is this one. So what will be this one? The time, the minimum development time is defined like this: 8.14 into LOC by P to the power 0.43. P is the productivity factor, and this will be for when the minimum time is greater than 6 months. Then you use it. And what about the effort? The effort will be 180 into B. B is the special skills factor. This also has a specific value for specific projects in person month. When the effort is higher than 20% month. T, as I said, you will use it here in years. Let us take an example here. You have to make a software package for a computer-aided design application, CAD application, for the mechanical components. Now you made the scope, you devised all the functions, and finally you are ready for the estimation. And let me tell you all we have done in the function point analysis, use case analysis. So we have the values. So I'm just putting the values. Say for this particular project, this is recommended value. P is 12,000. Assume it to be a scientific software. So P will be 12,000 for this particular problem or this software to be made. The line of code, as we already estimated earlier also, and we can give a number. So it will be 33,200. The B value is specific for this CAD software. There are other softwares, so there will be specific value, B value for, that is this special skill factor, because this CAD development needs a specialized skill factor from the team and the expertise they require. So we have 0.28 as B. LOC is 33,200. Now let us find out the time and the effort. So just put LOC as 33,200 here, and P you are going to put 12,000, and then you will get the time, which is the minimum development time, and the result will be like this: 8.14 into 33,200 divided by 12,000 raised to the power 0.43, and that is going to give you 12.6 calendar month. Now this is the calendar month, so you have to convert it into years. 12.6 month is equivalent to around 1.05 in years. So we are going to find out now the effort. So we have 12.6 as I just suggested. You can just convert it into years, and then you can apply 180 B T raised power 3, all 3 multiplied. So 12.6 is around 1.05. So just put it here in place of time. 180 B is, as I said, 0.28. So you get 58% month. This is how you compute value from the software equation.